Hey everyone, this is a question you can find on the Calculus Guy Instagram page which sets an expression to the power of another expression and the answer is set to be 1. I'm going to be starting in 3, 2, 1. So you should start and pause the video if you want to try and solve this and comment down your answers below. So let's start and solve this. So first thing I'll do is represent both of these expressions with variables. So our expression is basically a to the power of y is equals to 1. Now we need to find the cases in which this is possible. There are 3 cases in which this would be true. And most people find the first 2 cases but not the third one. So let's think about the first case. Well, it's quite obvious if y were equal to 0, then a could be anything. Any number to the power of 0 would be equal to 1. So if it was 23 to the power of 0, it would still be 1, and 40 to the power of 0 would also be 1. So if y were equal to 0, then we would get an answer of 1. That is the first case that we have. The second case in which this would be true was if a would be 1, because then y could be any number and a1 to the power of any number would be equal to 1. An example of this is that 1 to the power of 25 would also be 1, while 1 to the power of something like 3 would also be 1, and yet 1 to the power of something negative would also be 1. So y could be anything and a would have to be 1. The last case most people miss, but it is important to find the full set of solutions. The last case most people miss because of the fact that they don't consider that a could be negative 1. Yes, a could be negative 1, but in this case, y would have to be an even number. This case makes sense with examples. As you can see, if minus 1 were put to the power of something even, for example, if y were even in this case, for example, minus 1 would be given the power of 2, then it would be equal to 1. And minus 1 given the power of something like 4 would also be equal to 1. But if it's given the power of something odd, it would not be equal to 1 and would be equal to minus 1. Thus, let's start solving for the cases and then we can find the full set of solutions. So case 1 basically says that y is equal to 0. So we take the expression that we used to be equal to y and we put that equal to 0 and try and find the values of x that satisfy this expression. So x squared minus 5x minus 6x plus 30 is equal to 0. And thus when we middle term break this and factorize this, we get x minus 5 times x minus 6 is equal to 0. And thus the solutions of x that we get from this are x is equal to 5 and x is equal to 6. Now for case 2, what case 2 basically states here is that a would have to be 1 and y could be anything. So let's take the expression that we set as a, which is x squared minus 5x plus 5, and put it equal to 1. And now let's solve for the values of x that satisfy this and make the value of a be equal to 1. So we subtract 1 from both sides in order to get x squared minus 5x plus 4. Then we get, by middle term breaking, x squared minus 4x minus x plus 4 is equal to 0. And when we factorize this, we get x minus 4 times x minus 1 is equal to 0. Thus the solutions we get from this are x is equal to 4 and x is equal to 1. Now let's think about case 3. Case 3 basically states that a would be equal to minus 1 and y would have to be even. Let's think about the even part later. So in order to make a be equal to minus 1, we put the expression that we set as a and put that equal to minus 1. And now let's subtract minus 1 from both sides in order to get x squared minus 5x plus 6 is equal to 0. And then we get x squared minus 3x minus 2x plus 6 is equal to 0. And we factorize this as x minus 3 and x minus 2 is equal to 0. And now the values of x that we get from this are x is equal to 3 and x is equal to 2. Now we need to consider if y in these cases is even. How do we do this? We take the expression that we put as y and we put these two values in it and we see if the output is even. If it is even, then that means we consider it as one of the solutions because it turns minus 1 to 1. So let's insert 3 into it. 3 square minus 11 times 3 plus 30 basically equals to 9 minus 33 plus 30, which is equal to minus 24 plus 30. This is equal to 6, which is even, thus we consider 3 as a solution. Now let's insert 2 into the equation. So it becomes 2 square minus 11 times 2 plus 30, and this becomes 4 minus 22 plus 30. 4 minus 22 is minus 18 plus 30, which is equal to 12. And since these both values are even, then that means 3 and 2 are both considered valid solutions. And thus the answer is x is equal to 1, 2, 3, 4, 5, and 6.